Hey, welcome back to the channel. We're going to learn a few simple things about calculating torque. So we've got this great big board that's 10 meters long, and we are going to find the net torque about axis A. That means if we had put a hinge right here on the left side of this door, and all of these five forces are acting on the door, and we'll find out what the net torque is around axis A. So here's axis A again over here on the left side of the door. So we're going to say that we're setting the hinge right there. And if we go to calculate the total torque, well, there's going to be the potential for 5 terms in the torque since there are 5 forces on this door. And so we're just going to go one by one and look at what each of these 5 forces would do if the door were pinned here at a hinge at axis A. So let's get the torque about axis A. Well, that 20 Newton force is going to make no torque at all. It's pushing right on the hinge. You wouldn't be able to make the door rotate clockwise or counterclockwise. In fact, it wouldn't go anywhere if you pulled right on the hinge. And so that torque is going to be 0. If we move on to the 8 Newton force, that's here. Why, that's going to make the door rotate clockwise if that were the only force acting on it. And to find the torque created by the 8 Newton force, we have to multiply force times distance from axis. We multiply 8, the force 8 newtons, times 2 meters because it's 2 meters away. And that term is negative by sign convention because that will be a clockwise torque, right? The next force, the 7 Newton force, is directed in such a way that the line of the force goes right through the hinge. And so again, it's going to not make this door want to rotate at all. And so it's going to have no torque whatsoever. So no rotation caused by that 7 Newton force. So that torque is going to be 0. Finally, we get to the 18 Newton force. And this force is going to make the door rotate clockwise. And a way to see that is this component right here that is perpendicular to the door of that 18 Newton force. Why, that would make the door rotate clockwise if that were the only force acting on the door. So we have to peel off this part that's perpendicular. As you can see here, my little abbreviated definition of torque, I'm calling it F perp R. So this thing I'm blinking here is the F perp that goes along with the 18 Newton force. And so the length of that the strength of that force would be 18 sine 30. And so this term is going to be 18 sine 30 times 7 because we're 7 meters away from the axis. Now this term is also negative because that will make a clockwise torque. Finally, we get to our last term, and this one is actually going to make the door go counterclockwise. And how do I know that? Well, this component of the force that's perpendicular to the door, if that were the only force acting on the door, why, that would make the whole system go counterclockwise. And the length of that, or the strength of that little component that I'm blinking, would be 23 cosine 15. And then I have to multiply by 10 because that's the distance that I am away from the axis. So these are all of our terms in the torque. And if we add them all up, we end up with positive 143 Newton meters. Now, the reason this came out positive is this last torque term caused by this 23 Newton force, that dominated for a couple reasons. Number one is this 23 Newton force is almost pulling in an ideal direction to make this rotate. It's only 15 degrees off of being perpendicular, and it has the advantage of being very far away, so it kind of dominates. The 20 Newton force here was right on the axis, did nothing. The 8 Newton and the 18 Newton would try to make the door go clockwise, but they're sort of swamped out by this last term. Well, so the fact that this torque came out positive would mean that the door would rotate counterclockwise about axis A. Well, let's try this again. Now what we're going to do is find the torque about axis B. This would be an axis that's located here, basically 9 meters from the left-hand side of the door, or 1 meter from the right-hand side. So add this little detail that axis B is 9 meters from the left and 1 meter from the right. And what we're going to do is we're going to find that torque about that axis B here. You could pause the video and have your class give it a shot. to try to get the 5 terms of torque about axis B. But I will take a look at it myself right now. So again, we have the potential for 5 terms because there are 5 forces acting on the door, but now we're pretending that it's pinned right here. So we've moved the hinge. The hinge is no longer at axis A. We're going to try to see what the torque would be if we were to pin it at axis B. So here we go. Torque about axis B. Let's go left to right again. So that 20 Newton force, which made no torque about axis A, will now make a torque about axis B. It would make it go clockwise about axis B if I pushed up over here. And it's going to be negative because it's clockwise, and then it's a force of 20 times 9 meters away from axis B. So 20 times 9. We did not need to do any trigonometry because that force is already perpendicular to the door. Now we get to this 8 Newton force. Well, that 8 Newton force is going to make it go counterclockwise if it were the only force acting on the door, and it was pegged at axis B. And so, and it's already perpendicular. So we're just going to take that force times its distance from the axis. So this term will be positive because it's counterclockwise, and it'll be 8 newtons times 7 meters away, because the distance between 2 meters and the axis over here at 9 meters would be 7. Finally, we get to the 7 Newton force, but its line of action is right along the door. So its line of action goes right through axis B. It wouldn't make the door rotate clockwise or counterclockwise. So no torque from the 7 Newton force. Finally, we get to the 18 Newton. That's going to go counterclockwise. Now, why? Because this component right here of the 18 Newton force that's perpendicular to the door would make it go counterclockwise about axis B if it were the only force acting. And the strength of that component is 18 sine 30. So it's going to be plus 18 sine 30 times 2 meters away, because the distance between the place of action of the force at 7 is 2 meters away from the axis, which is at 9. So 18 sine 30 times 2, and that's positive because it's counterclockwise. Notice that the 23 Newton force and the 18 both want this thing to go counterclockwise. They would sort of set it up to circulate like this. And so this is going to be another positive term because of being counterclockwise. And it's because this component right here, which is perpendicular to the door, would cause it to rotate. And that's going to be 23 cos 15. And then we'll multiply by 1 because the end of the door at 10 meters is only 1 meter away from the axis. Well, if you total all these up, you'll get a negative number. And that's because this 20 Newton force that's way over here will dominate because it's a large force and it's far away, which gives it quite a big torque, or quite a big effect. The other forces that cause torques all tended to cause a counterclockwise one, but they are, well, either too close or too small to make up for this huge torque created by the 20 Newton force, this negative torque. It's going to be a clockwise rotation about axis B, again, because the clockwise torque created by the 20 Newton force will dominate. So hopefully you found that helpful, and thanks for tuning in.